Okay, so maybe you gave it some thought. So now let's discuss further. So here we have three capacitors connected in series, and we have connected to a battery. By the way, this battery will send a charge plus Q and a minus Q here. Small mistake I made, right? So now we need to find what is the effective capacitance, and effective capacitance should be such that if you just think these three were equivalent to one capacitor, right? Then if we connect it to this V, this Q would be same as this Q, in which case Q upon V, which is the C, will be same as this Q upon this V, right? So how do you do this? So let's now connect this to this battery and then see what happens. So now let's do that. So when I connect to battery, a charge will flow. Let us say charge is flowing here, and there's plus Q going here, minus Q going here. Right? Now what will happen? Now between these two, between A1 and A6, between A1 and A6, right? These two have, A1 has got charge plus Q1 and A6 has got charge, plus Q, and A6 has got charge minus Q, right? Now what will happen? Now this plus Q will exert a force in this direction, this minus Q also will exert a, so basically there will be a net electric field in this direction. There will be a net electric field in this direction. What will that do? That electric field will pull the electrons. So here if there is an electron, this electron will feel a pull towards this. So now the electrons will start moving. Electrons will start moving here, right? Until the field outside becomes zero. When will that happen? That will happen when here we have minus Q. So this plus Q, then we'll have minus Q here. And since the whole thing is electrically neutral, if this is minus Q, this has to be plus Q, right? Because this part of the circuit, it does not have any net charge. Same logic, extend the same logic here. So this will also have a charge of, so this is plus Q, so this will have a charge of minus Q, and again this will have a charge of plus Q, right? So as you can see here, plus Q, minus Q, plus Q, minus Q, plus Q, minus Q, right? So each plate will have an alternatively changing sign, but the same charge. Now what about the voltage, right? The voltage V. So let us say the voltage across this capacitor, let's say is V1, this voltage let us say V2, and this voltage is V3, right? If we go from here to here, we'll say, what do we get? We'll basically get that the voltage difference here between these two is V. So V is going to be equal to V1 plus V2 plus V3, right? So my total potential difference between these 2 points is V, which will be sum of V1 plus V2 plus V3. So we will have V1 is equal, V is equal to V1 plus V2 plus V3. Now what is V for each one of them? So now we know that Q is equal to CV, right? Which means this implies that V is equal to Q upon C, right? Now this one, the first one has got capacitance C1, C2 and C3. So now we can say that by this logic, V1 is equal to Q1, right? Q1 upon C1. What is Q1? Q1 is nothing but Q, which is going to be equal to, C1, which is going to be equal to Q upon C. Similarly, V2 would be equal to, by same logic, C1. This will be equal to Q upon C2, and then finally, we'll have V3 is equal to Q upon C3, right? So we have this equation 1, and this is 2, this is 3, right? This is my 2, and this equation is my 3, right? Now I can substitute these three in this equation. I can put 1, 2 and 3 in this equation. I can get my total voltage V, right, is going to be equal to V1 plus V2 plus V3, which will be nothing but Q upon C1 plus Q upon C2 plus Q upon C3, right, which is nothing but Q into 1 upon C1 plus 1 upon C2 plus 1 upon C3. Right? Very, very straight algebra, nothing very complicated. And what did we say? We said if these three are equivalent, these three are equivalent to one capacitor, right? Then in that case, when I connect V, the same charge Q should flow to them. So here what we can see for this is my C, let us say C effective. So from here I can say that C effective, right, is equal to what? Is equal to Q upon V, right? C is, or we can say Q into C effective. Q effective is equal to C is going to be equal to Q by V, right? So C effective is going to be equal to Q by V, and therefore we can say V is equal to Q upon C effective, right? And what is this equal to? This is nothing but equal to Q into this whole thing. This is equal to Q into 1 upon C1 plus 1 upon C2 plus 1 upon C3, right? And now this equation, this Q we can cancel, and therefore we have 1 upon C effective, right, is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3, right? This is the, so now we have, this is the way we can find the total capacitance or effective capacitance, right, for when capacitors are in series, right? And now we can solve some problems using this principle, right? So just make sure that you understand the steps involved, right? And that you can derive this totally on your own, right? So you have to do this derivation on your own after you have understood this. Thank you.